morning, friends. After exhausting ourselves with huge expressions, we decided that we will try to see what are the information we get from one-dimensional analysis of pitching motion, yawing motion and rolling motion. And you will see how important are these in designing stability augmentation system. We have already done longitudinal case. If I take pure yaw, that is only this yaw motion is allowed. Okay? And as you know, as far as yaw is concerned, when the right wing goes back, that is a positive yawing moment. When I am flying like this and right wing goes back, that is a positive yawing moment. And you also know that IZZ R dot is equal to yawing moment n, where R is the yaw rate, and n I can write it as half rho v square S b into CNP into PB by 2 U1 plus CNR into RB by 2 U1. Let me write R like this, plus Cn beta into beta plus Cn delta R into delta R. I am neglecting any contribution because of beta dot or delta A, both. This I am neglecting. Both beta and delta contribution, beta dot and delta contribution I am neglecting. You know, beta dot is like alpha dot for longitudinal plane, and beta dot is because of side wash, rate of change of side wash on the, especially on the vertical tail, which I am neglecting. It should not confuse you. So, let me erase this part. I write it here that beta dot and delta A effect are neglected. So, this is the equation I have got. Again, you are now expert. I write R dot equal to what? R dot is nothing but psi double dot. Remember, because psi dot is basically R. The yaw rate, if there are no bank, just we are talking about this. So, psi dot is basically R, and R double dot is psi double dot. And also we know that psi equal to minus beta. Remember, if this is the airplane, this is psi equal to 0, relative wind is coming like this. If I turn the airplane like this, then this is the psi, and this is relative air is coming like this. So, this is also minus beta, right? Because positive beta we have defined, relative wind coming from the right hand side. So, if there is no bank, it is yawing in the horizontal plane, then psi equal to minus beta, right. So, now if I translate this equation using this, then I get IZZ psi double dot is equal to, I can write this Q SB, where Q is the dynamic pressure, into CNP into PB by 2U1 plus CN R into RB by 2U1 and plus Cn beta into beta plus Cn delta R into delta R, right. But what we are looking for, we are writing the equation in psi. We know psi equal to minus beta. So, here I will write this term, I will write as plus Cn beta into psi with a minus sign. And here this R, I will write CNR into psi dot b by 2u1. Is this clear what I have done? Psi dot is r. So, for r I have written psi dot and beta equal to minus psi. So, this minus psi. Okay, very simple. So, finally, the equation takes a form psi double dot equal to, I can write n p into p plus n r into r plus n beta into beta plus n delta r into delta r. Right. So, what is NP? NP is nothing but, from here you can see NP is nothing but Q S B C N P B by 2U1 divided by I Z Z. Okay. Similarly, CNR, or sorry, edit. Similarly, NR will be CNR into B by 2U1 into QSB divided by IZZ. Like that you can find this expression, which already you know. And of course, here I have to modify it. I write it as psi dot and I write minus this. Okay. What I have done from this equation, beta equal to minus psi and psi dot equal to r. So, all those things I have converted into psi dot. Now, if the airplane is doing only pure yaw like this, then there is no P, right? We are not doing this motion, we are only doing this motion. So, naturally, I will say thank you very much. This term goes. So, I have got psi double dot is equal to NR into psi dot minus n beta into psi plus n delta r into delta r. So, I can write this as psi double dot minus nr psi dot plus n beta into psi is equal to n delta r into delta r. Again you see pure yaw motion when we are modeling, we are again getting a second order differential equation, and which is same, the form is same as mass spring damper system equations of motion, and we know how to handle that. From this equation I can write omega will be equal to under root of n beta, and similarly 2 zeta omega will be omega n will be equal to minus n r. Remember, for longitudinal case it was omega n was minus m alpha, right. So, now see the beauty. If you want to change omega n, this clearly tells you you have to handle C n beta. And how can you handle C n beta? How can you change C n beta? You know, it is through vertical tail volume ratio. Okay. That means either we increase the vertical tail area or increase the length of the vertical tail from the, or distance of the vertical tail from the CG of the airplane. Once this is done, then we have to do the pure roll. Let us see what we understand from pure roll and how can those informations I can use for designing a stability augmentation system. So, let us discuss about pure roll. And before we discuss this, please understand pure roll we are meaning thereby this is the pure roll, right. But you know, as I roll like this, the angle of attack here will increase. So, drag also will increase here. So, that will give me a yawing moment also. Like when you are doing yawing moment like this, so the lift here will increase, it will give a roll also. But we are seeing only one dimensional motion, that is we are only talking about pure roll, no yaw motion, right. So, again if I write the equation for that, this is rotation about x axis, this is equal to rolling moment, that is equal to half rho v square SB into CLP into PB by 2U1 plus CL beta into beta plus CL R into R B by 2U1 plus CL delta A into delta A. This is a generic form, but you know it is a pure role. Since it is a pure role, beta is not there, R is not there. It is only I am doing pure role, this. No beta or no Yawing. If I do this, then I get IXX P dot equal to QSB into CLP into PB by 2U1 plus CL delta A into delta A, because this goes, this is R means this is the R, this is also this R, this also goes, okay, so 0, 0. So this is the form, and I can easily write P dot equal to LP into P plus L delta A into delta A. So simple. And what is LP? LP is, what will be LP? LP will be equal to QSB by IXS CLP into B by 2U1. Similarly, CL delta you can find out. And you could see this. This is a first order differential equation, and you can easily find out the expression of P, and this P will be given by minus L delta A into delta A. Let me write this, divided by LP into 1 minus e to the power LP into T. And easily you can find, because phi dot is equal to P. We are only doing one dimensional role, and phi is the bank angle. So from here you can find out phi T equal to minus L delta A into delta A by LP into T plus L delta A into delta A by LP square 1 by e to the power LPT minus 1. So what is the message if I try to read PT, P of t, that as time goes to infinity or for large time, since LP is negative, so this gentleman will go to approach to 0. So P of steady state, that is at t approaching infinity, this will be minus L delta A into delta A by LP. Okay. So depending upon what type of delta aileron you have given, whether step input, pulse, impulse, whatever it is, right. So you know what will be the steady state value. And for phi also you have seen this, LPT is negative. So as your time increases, this LPT e to the power 0, as time tends to infinity, this whole will become e to the power minus t, but t tends to infinity. So this goes to 1, and then phi also approaches a value which constantly increases with time t as time increases. So that if I try to plot it, how will it look like? Let us plot phi t versus t, and you could see that the variation is like this. So phi goes on increasing with time, but interestingly you could see if I take a slope at some point, that phi dot at this point is basically P steady state, and that slope you can draw at some point, which will correspond to time equal to t equal to TR. And if I try to see what is phi dot doing, phi dot versus time, you will find that it is so this is PSS or steady state P. You could see phi of t is L delta by LP and L delta into delta by LP square e to the power LPT minus 1, and we know LPT is negative. So, if I plot it like this, it will reach P steady state as time goes to infinity, right. This is here. As time goes to infinity, this gentleman goes to 0, and so you have P steady state as L delta into delta A by LP. This is which is given here, just I am repeating. But the question what we are looking for is not on understanding the variation. Question is, if I try to alter the rate at which P of t is increasing or going asymptotically to a steady state value, I have LPT, LP here. I have to do something with LP, roll damping, which is lying here. Because L delta is active, so comes through aileron. So, and LP, which is the roll damping, they decides the stability. Okay? So, in stability augmentation system, also we know if you want to tweak the roll response, I need to play around with LP. That is very important. Okay? So, if I again come back here, this is the phi of t variation, this is phi dot t variation, which are coming from, this is for phi dot t and this is for phi t, and you can see that the variation goes like this. And we also realize that if I want to do something with the roll response, the LP, which is the roll damping derivative, I have to play around with that. See this one dimension analysis for longitudinal, we identified Cm alpha is the key parameter, Cmq is the key parameter. For directional, we found Cn beta and CNR. Okay. And for roll, we found CLP. So, we have seen that for longitudinal case, it is Cm alpha, Cmq, and for directional case, it is Cn beta, CNR, and for roll, it is CLP. That plays important role. When I coming to roll, I also get a notice of this term TR. I am sure you would like to know what is TR. TR, otherwise it will not be complete. So, say at t equal to minus 1 by LP, which I call TR, time constant at roll. If t is equal to 1 by LP TR, so 1 by LP TR means e to the power LP LT, that is LP into minus 1 by LP. Okay? This t is minus 1 by LP. So, LP gets cancelled, and then you have P at TR equal to, you can check, it is minus L delta A into delta A by LP into 1 minus e to the power minus 1, and which is close to 0.63 of P steady state. So, you can understand that roll time constant TR, this is roll time constant, very important information it gives for a designer. The roll time constant TR is that time at which the value of P goes to 63% of the steady state value. Okay? Most of our design you will find this 63% of the steady state value plays an important role in freezing the initial design parameters. So, I thought I must complete this. Now, I think we are ready for venturing into stability augmentation system. stability augmentation system. What does actually mean? Let us say I take longitudinal case, right. We will be mostly focusing on omega n and zeta through handling qualities of airplane, which I will talk next lecture. But just to warm up you, for longitudinal case, if there is a requirement of increasing omega n, that means omega n, we know from approximate analysis it is proportional to minus m alpha, which is nothing but minus half rho v square s Cm alpha by Iyy, and C will come here, C, right. If you want to increase omega n, natural frequency, longitudinal pitching motion, short period, you could see how can I increase this. Before I talk of increasing this, I see that omega n will vary with rho, with v. This is very important that as I go higher and higher, the omega n will go on reducing. Similarly, as I go on increasing the speed, the omega n will go on increasing, right. This is very, very important to observe. Also, I see I can tweak the omega n by changing Cm alpha. And the problem is, what is Cm alpha? Cm alpha has direct link with stability margin, that you know. So, you cannot go on changing the stability margin in flight. Okay. But if at all, at the beginning you have to change omega n, and if you decided to change through Cm alpha, that means if this is your horizontal tail, and suppose somewhere here there is a CG, so you have to increase tail volume ratio. That is, either you increase the size or draw it backward, because VH is ST LT by SC bar wing. So, if you want to increase Cm alpha, you have to increase tail volume ratio. That means increase tail area or this length from AC of the tail, CG of the airplane. So, the initial stage, once you have done it, now you do not have option to change it. That is not a very good design. Okay. However, as you see, omega n changes with density, changes with V. So, you may not be very happy with the initial design, whatever it is. You may online change the value of omega n depending upon what is the density of air, at what altitude you are flying, what speed you are flying. So, you want something which I can do it online or flying, and if required, it should automatically change it to the requirement which satisfy the pilot's flying qualities requirements, right. So, that is where we need to have a stability augmentation system, and this is true for directional as well as roll. So, from next class or next lecture, I will be focusing on stability augmentation system. I hope up to this point, after fighting through huge expression, finally you see I have tried to narrow down to a very simplistic expression from the designer's perspective. Once you freeze the parameter with this simplistic approach, you can go back and go up to the exact equation and find out the final characteristics of the airplane. That was the aim. Thank you very much.